Good morning all. Glad to see you all up and about. Now today we're going to test this Allen Bradley input module, and it is catalog number 1791-32A0. There are 32 inputs to this module. 8 right here, 8 right here, 8 over here, and 8 over here. And they go to an optocoupler input. And the output of that optocoupler goes to a microcontroller. And the microcontroller will turn on the corresponding LED for each input that's made. These LEDs right here make it really nice to troubleshoot. Now, this unit takes 120 volts AC to power it up. And terminal 1 right here, L1, and terminal 3 right here is L2. And underneath terminal 2 is frame ground. Now I have these red wires going to the L1 side of the input optocoupler. I'll show you my drawings of that circuitry that I've got mapped out. So in order to make an input, to activate that input, we have to pull the other side of the optocoupler to L2. And right here is my PIC connected to L2. Don't touch that metal. Don't touch that metal. You don't want to get shocked. But this is the easiest way I have found where I can activate those inputs. Otherwise, we'd have to have a switch or some way to switch each input, and it would just take too much hardware and too long to wire it up, so I use that PIC. Just be careful. Now, we're going to get the camera a little bit closer to this unit so you can see the LEDs when I power this unit up. Right here are the wiring diagrams from the PDF on this unit. And I'll put these up at the end of the video so you can wire up your input module and test it. Alright, let's power up the input module. We've just applied 120 volts AC to L1 and L2, and you can see that the COM LED is off and the status LED is blinking. That indicates that there's no communications into this input module. That's an alarm. Let's go ahead and test the inputs. We're going to take L2 and touch it right there on that terminal. And you can see that the input has been made by that LED turning on. Let's go to the next one. So far, so good. There are the 8 inputs that have been made on that side. Let's go to this one. This is the second row. Get on it. There you go. Now there's the 8 inputs of the second row. Now we're going to go to the other side. This is row 3. Those 8 inputs work. and the last 8 inputs work. The inputs are functioning. Now when you make that input, the output side of the optocoupler has, I believe it's 0 to 5 volt 60 hertz pulses, 5 volts peak, and that goes directly into the microcontroller. And the microcontroller, when it sees that 60 hertz 5 volt peak pulses, turns on the corresponding LED. And I imagine also it would route communications back out to the PLC indicating that input was made. All right. We're going to power down and we're going to look at another unit that I have taken apart. And you can see those pulses when I make that input. Here's kind of what's inside. Let me pull up the chair. Okay, right here is the microcontroller. It's a custom microcontroller. Has an Allen Bradley label on it. Here are the optocouplers for the input. This is one side right here. Let's flip this over. Here's the other side right here. And here's the optocouplers for the other side. Be very careful, because you're going to have low voltage and high voltage floating around here. You don't want to get the high voltage on the microcontroller side. It'll wipe it out. There will be no coming back from that. So I'm going to make this input, and we're going to look at this connector right here, if I can get on it. They're very tiny pins. Then you'll see what it looks like from the output side, the input side of the optocoupler, and the output side of the optocoupler. Did I get that right? No, wait a minute. We're looking at the output side of the optocoupler on this ribbon cable. Whew. Come on, brain, engage. Okay. You know what I'm going to do? I'm going to get a piece of paper to put between here and there. That way we'll try and keep everybody separated. Okay, let me get some scissors here. Okay. Let's put that right there. Okay. Don't flip over. All right, let's power up. All right, we have our status LED blinking. The COM LED is off. I'm going to turn on the oscilloscope here. Now, what we'll do is move the camera over there in front of the oscilloscope, and I'll tag that input, and we'll look at the output side of the optocoupler going to the microcontroller, and you'll be able to see what it looks like. With this opened up like this, you have to be very careful, because you don't want 115 volts to jump on this board right here. Your day will be over after that if that happens. So be very, very careful. Okay, without that input being made, we'll take a look and see what the output of that optocoupler looks like. This is one output. There are 32 outputs of optocoupler, 32 inputs. And there we have a peak of 5 volts. That's with that input not made. Now I'm going to remove the probe, and we're going to hook that input up to L2. Get on here. Okay. Now there's that input connected to L2. And we'll take a look and see what that same pin on that ribbon cable looks like. There it is. That is the output of the optocoupler. 5-volt peak, pulses at 60 Hertz. That's with that input being made. Okay, removing the probe from that pin on that ribbon cable. We're going to power down. Now you know what the output side of the optocoupler looks like. This is also a good unit. I need to reassemble it. After we get done here, I'll do that. A very nice system that they got together here for this input module. Alright all, hope you enjoyed that video. Thank you for stopping by. See what we're doing next. Have you a good day.